Life has problems. Let's find solutions. You made it. Hopefully you've watched the other sig fig rule videos and you know a thing or two about addition subtraction rules and you know something about the multiplication and division rules. You need to understand those ideas before this video is going to make any sense, because now we are going to deal with the types of problems where you've got a mixture of rules. Problems where maybe you've got some addition going on, but you're also going to divide that later on, or you have to multiply these two numbers together before you subtract it from some other value. Let me show you what we're talking about here. I like to call these problems switching gears, because you're switching from one rule system to the other. Look at a problem like this. We've got a mixture of subtraction at the top in the numerator position, and we've got addition here at the bottom, but we also have division going on. And what we have to do is, if you look at a problem like this and you've only learned those two sets of rules, you might ask, well, which set do we use? And the truth is, we're going to use both sets, and we're going to use them at different times. We've got to know when to use them. I think that as students have taken my AP Chemistry course, this is probably the video that past years wish I had made, and they'd want to review this often. When do you switch gears? When do I do some rounding in between? In the previous videos, when we were dealing with all just the same kind of rule, addition-subtraction rules, or a problem where there was a lot going on but it was all multiplication division, we would not do any in-between rounding. That was a big forbidden thing to do. You don't want to do any in-between rounding until you get to the end. But in a switching gears type of problem, you are going to have to do some in-between rounding. You must do some in-between rounding. So what I have to do actually is I'm going to treat this quantity here, this subtraction problem, as a separate problem, and I am going to have to round the raw answer before I divide it by whatever this down here ends up being. This denominator position, where I'm just adding these two values together, I'm going to do this first because of order of operations, and that's going to be the addition subtraction type of rule system. And then before I divide that into my numerator, whatever that ends up being, I am going to have to round this using addition subtraction rules. Once I've done that and I get these two rounded values, then I'm going to divide the numerator by the denominator, and I'm going to use multiplication division rules to come up with my rounded answer. Alright, so let's go ahead and try this. We're going to treat this like a separate problem. I'm going to put over here my raw values. 14.8 minus 2.79 gives me 12.01 raw. So 12.01, and I'm just going to say raw, just so I remember as I'm writing it down. And that's going to be divided by 10.7 plus 105. So I've got to add 10.7 plus 105, and I get 115.7. 115.7. All of this is raw. This is raw too. Now I've got to round these values before I can divide them into each other. And I'm going to have to use the data that created each number. So in other words, I can't use, oh hey, this one's only gone to the ones place for my 105 and make that influence how I'm going to round the numerator, because this was only something that supplied the denominator with its value. So again, treat it like separate problems. So I'm just going to cover this up, and I'm going to say, all right, if this had just been my separate problem, I would have said that my precision, I'm the least precise here at the tenths place. Over here, this goes to the hundredths place, this one only goes to the tenths. So I've got to round to the tenths place. So that means I'm going to have to call this, when rounded, 12.0. And that next number was not 5 or greater, so it just fell off. Now, I don't want to call it 12, because that'd be too much rounding. I'd be losing some information. I do know, I have some confidence about that 0 there, so I want to make sure I keep that sig fig. I'm going to divide that by, well, let's see what this denominator turns out to be. 10.7 is only precise to the tenths place, but 105 has only precision to the ones place. And so that's going to limit my precision down here in the denominator. So I need to round to the ones place. That's going to make this 116. And now when I look at this problem, this is now a little bit simpler, and now I'm going to use division rules, and I can already see my numerator has how many sig figs now? 1, 2, 3. It's got 3 sig figs. My denominator has also 3 sig figs. It's a good thing I kept this 0.0. If I had ignored that and just called it 12, then I would have lost one of my sig figs, and when I was counting these up, I'd think that I need an answer that's rounded to 2 sig figs, when really I need one that's rounded to 3. My numerator and my denominator both have 3 sig figs. So it doesn't matter which one I say is limiting it. The point is my answer's got to have 3 sig figs. So as I carry this on then, 12 And if I want to just, be thorough, I can say 0.0 on my calculator. I know that 0.00. My calculator doesn't need to know, but I'm going to do it for the video. And I'm going to divide this by 116. And here's my raw answer. I'm getting 0.103448, blah, blah, blah. And so I'm going to round that to 2 sig figs. So this is going to become 0. I'm sorry. I almost made a mistake there. I'm going to count it as 3 sig figs. I'm going to have to round this to 3 sig figs. So I'm going to call this 1, 0, and then before I write the 3, I check the next number. It's not 5 or above, so I'm going to call this 0.103. There's my rounded answer. Okay, let's see if you're getting this. Let's give you one to try. Here is your problem. Check that out. You even got a 3-legged turtle giving you words of encouragement there. Go ahead and give this a shot. Pause the video. Work this out. Don't forget when to switch gears. Review the video if you need to go back over that again. See if you get an answer, arrive at your answer, and then check it with mine. Go ahead and pause the video now. Alright, let's go ahead and work through this then. So here's what I'm seeing when I look at this. I see that I'm going to divide these two numbers and then I'm going to subtract some stuff from it. So this here is a separate problem that involves multiplication and division. So that's a separate problem. I'm going to round before I subtract something from it. That thing I'm going to subtract from it is this right here. And I've got 16.2 times 4. And then I'm going to divide it by 0.55. Well, that's all multiplication and division. I don't need to multiply this and then round it before I divide by 0.55. Instead, this is its own separate multiplication division problem. We're all in the same realm here. So I don't need to switch gears. When I go from the numerator and then I find out what that is and then I divide it by the denominator, I'm not switching gears. That's still within the rules of multiplication and division. So these 3 data points, when calculated together, that's all within the same value system, same rule system. So I do not need to switch gears when I'm doing this stuff here inside of my red parentheses. But I will have to round that before I subtract it from whatever this winds up being. And then I'm adding 117 to it. Another reason why I'd have to round this before I add 117. Okay, so let's find out first, what is this over here? I can see since I'm dividing, I'm going to use division sig fig rules, and that's all about rounding to my least number of sig figs. 406 has 3, but 0.13 only has 2 sig figs. So this, whatever this ends up being, has to be rounded to 2 sig figs. I got 406 divided by 0.13. I've got 3,123 or so. So I've got to round that to 2 sig figs. That's going to be 3,100. So here I've got 3,100 already rounded with just 2 sig figs in that number. Okay, I'm going to subtract from that whatever this winds up being. Notice I've got, again, multiplication, division going on, so that's all about least number of sig figs. 16.2 has 3, but 4 only has 1. 0.55 has 2. So all of this has to be rounded to just 1 sig fig. 16.2 multiplied by 4, and then divided by what? Divided by 0.55. I've got 117.818. It's got to be rounded to 1 sig fig. Well, then that's just 100. 117.8 is going to be rounded to 100. So I'm going to subtract from that 100. And that really is just 1 sig fig there. And then I'm going to add to that 117. So now I'm in addition subtraction rules. I've got 3,100. That has precision now. It's all about the amount of precision it has. Precision to the hundreds place. My 100 has precision only to the hundreds place. My 117 has precision to the ones place. So with those values, my answer is going to have precision to the hundreds place. So let's go ahead and add these all together. 3,100 plus 100 plus 117 gives us a raw value 3,317. So I'm getting 3,317 raw, but that then is going to round to the hundreds place, 3,300, and then the next number is a 1, so that doesn't round it up, so 3,300. Is that what you got? Hope it was. You know, this is, I think, one of the most challenging things when it comes to doing your calculations for college classes, for more advanced classes, having to work with significant figures. And I don't claim that this is the only rule that some colleges will teach, but this is the most popular rule as far as these two rules together and how to combine them. And so you're going to have to know them for my class most definitely. And it's something you can't give up on. I get through the school year and I have students that even in the later chapters, they realize, I never really caught on to the switching gears concept. It's something you need to know early on in the course, because once you master it, you won't lose it. But it can cost you points all throughout the course if you don't get it early. So, the three-legged turtle, back to that. I did meet a three-legged turtle once at the Shed Aquarium. He was trying so hard to get up onto this log, to crawl up further up onto it, and he was trying with 3 legs. He had some odds against him. The log was slippery, covered with some mossy slime. He only had 3 legs. He was going like a true warrior. The turtle was working hard, is the point I'm getting at. And he was trying so hard, and he fell in. And after that, you know what he did? Man, he didn't sit there and say, I'm done with this, and give up. He went back, and he tried again, and he tried again. And I watched him sit there and try. I never actually saw him get up the log. But he did not give up. If a 3-legged turtle can keep on working at it, you can too. If you don't get this concept at first, if you give up, if you stop trying to learn it, it doesn't just come to you one night. You don't just wake up one day and be like, oh my gosh, I get it. I know how to switch gears now. You've got to keep on trying with it. Keep practicing until you get it. As soon as you stop trying, you are not going to get it. All right, good luck out there with it, and check out future videos. Ciao.